Hello, everybody, and welcome to yet another recorded Zoom interview. This time we're going from North America to Tasmania. Dr. Jacqueline Halpin, University of Tasmania. Jackie, what's the weather like this morning in Hobart?
Look, it's pretty springy, I would say. Yeah, spring, it's all over the place in Hobart. A bit windy. It's okay at the moment. And in the background I'm in Northwest Tassie.
Oh,
So
perfect.
got a bit of
Good.
both.
You really did your homework. Thank you. Yeah. So viewers, let me talk directly to you for just a second, and then we'll get into it with Jackie. Um, Long ago, more than 40 years ago, I took a summer job in Glacier National Park in Montana. And that's one of the reasons I got interested in geology because I couldn't believe that the upper half of those Montana mountains in the Rocky Mountains were some of the oldest rocks in North America sitting on top of these younger rocks down below. It's called the Belt-Purcell Supergroup. Hadn't thought much about the Belt-Purcell since then, Jackie. Very little, but I'm newly interested in the topic. And I'm coming to you because a viewer named Robert in Vancouver, British Columbia, sent me a few papers by email. He said, I see you're thinking about the Belt-Purcell. Did you know that there's this paper from 2014 written by Jackie that talks about a connection between our Precambrian rocks and yours? So, do you really have a match over there in Tasmania?
Well, we think so, yeah.
Yes.
Yeah, it's Tassie's older than we thought, turns out.
Okay. What part of the country are we talking about, and how did you get into this possible connection with North American rocks?
Yeah, sure. So the scenery behind me, we're in Northwest Tassie here. So
Mhm.
these rocks are called the Rocky Cape Group, and they crop out along the coast and also inland in the far northwest of Tasmania. So that's maybe 5 hours from where I am in Hobart,
Okay.
driving quite a wiggly road up there.
Yeah.
And yeah, this area, it's pretty spectacular. There's these beautiful formations of quartzites and siltstones, shales. And we thought they were old, but we didn't really know how old.
Hmm.
And so, yeah, about 10 years ago or so, there was some interest because some interesting fossils were found in the rocks. And
Okay.
all of a sudden, it was like, hang on, how old are these rocks really? Yeah. And so
Well,
that's how I got involved.
good. I know you've got some slides, and I want to get into that. And viewers, Jackie's paper, and again, it's a 10-year-old paper, and I think, well, I'll stop right now. Jackie, you've been supervising some grad students since then, so maybe there's evolution of some of this story. Is that fair to say?
Oh yeah, for sure. There's
Okay.
always an evolution. Yeah.
Yes, that's right. Exactly.
Yeah.
But we're going to feature Jackie's 2014 paper today. And if you go to my website, nickzentner.com, and click on Alaska, of all places, in the upper right-hand corner, Jackie is one of the four papers that are there for you right now, 2014 paper. Before we go to your slides, Jackie, I can feel the confusion from many of the viewers right now. How in the world? Tasmania is just south of Australia on the other side of the Pacific. Why are we even talking about this as a possible connection? So, how old are these rocks, and how is it possible they could have been connected at one point?
Yeah, that's right. We're a long way away today,
Yes.
but we have to cast our minds back a fair way back. So we're talking over 1 billion years ago. And these rocks in Tasmania, they actually look nothing like the Australian mainland. So that's always been confusing as well. Australia sometimes likes to forget about Tasmania and thinks we're a bit different. We're a little bit different. We do things differently down here, and turns out we are a bit different. There's a good reason for that, I think.
Wild. So, some of the oldest, or are they the oldest bedrock units in Tasmania?
Yeah, so we don't have any basement rocks exposed. So this is as old as it gets in Tassie. Yeah.
Wow. And
hmm
and those old rocks do not match anything it appears in Australia, but the matches with us. And Antarctica, I know you're an Antarctic geologist as well. Is there some of this Belt Purcell in Antarctica?
Yeah, that's an interesting question. I think our work showed that some of the sediments coming into this basin that the Rocky Cape Group represents probably came from Antarctica.
Ah,
Whether there's related rocks, I don't think we know enough.
Okay.
from the Antarctic part of the world. Yeah, to say that.
Okay, well done. You're a natural, number one. I can tell that you teach. This is easy, and I think that's enough of a tease to get us into a few of these slides. And occasionally, I'll get real excited and want to get off the slides. But let's go ahead and feature some of the elements of your paper, and then I'm guessing you'll want to kind of spitball beyond that as well. So please share your screen whenever you're ready. Um,
Yeah.
this is such a thrill. I'm so grateful. I mean, I just emailed you out of the blue, basically, and here you are. So this is wonderful. Okay, well, I'm ready to settle in. Beautiful slide. Let's go, Jackie.
Yeah, cool. So up in the top left, you can see a map of Tassie. So there's a little inset there. There's Tasmania. We have a few islands off the top, King Island on the northwest there. And then this inset with the colors that shows the geology. So the Rocky Cape Group, we're right up in this northwest part of Tassie.
Mm-hmm.
And it's the greens and blues and purples you can see in the map
Okay,
there.
thank you.
Um, and the stratigraphy is shown there. It's about 10 kilometers of sedimentary rocks the
Huh,
Rocky Cape Group
huh,
represents. It's quite thick.
yeah.
And in the middle, you can see in Tasmania, we have these Proterozoic rocks only on the western side of Tasmania. So the Rocky Cape Group itself is in the northwest, but we have correlated kinds of rocks that crop out in the highlands further to the south and the southwest as well.
Hmm.
And so, yeah, as I said, there were these interesting fossils that were discovered. So the newspaper clipping on the bottom left there shows the front or one of the pages of the local newspaper about 15 years ago, where a local prospector, Marty, who's the one holding the rock there, he found these beautiful patterns in the rocks that he was picking up for his front porch. He was building a veranda. He wanted to lay some of the local stone, and he found these strange markings, and he thought, he knew enough about rocks to know this was something interesting. He called around and got some more people involved. So Clive Calver in the background, who's worked in Tasmania for a very long time,
Hmm.
knew exactly what they were in the end. They
Hmm.
were these fossils Horodischia. So they're sometimes known as string of beads. We don't really know what they represent. I think there's still a lot of debate about that, but
Sure.
I think the most recent idea is that they're very early multicellular life forms, eukaryotes, and so they are found in only a few places around the world. So one of the key places they found, and the first place they were ever found, was in the Belt-Purcell in Montana.
Wow.
So yeah, when these fossils were found in Tasmania, suddenly it was like, okay. That's interesting because we didn't really think the rocks were that old to be the same old age as the Belt-Purcell in Montana. So these fossils are also found in other places in Western Australia, Siberia, and China. So there was, I guess, an interest there. It's like, okay, so what are the Tasmanian varieties? How are they related to other varieties around the world? And could the rocks actually be older than we thought they were? So that kind of set the ball rolling for us to learn a bit more about this Rocky Cape group.
Well, that's an interesting angle because it's if you have such a thick pile of originally sedimentary rocks, I suppose it's difficult to keep track of time anyway. Is that an accurate statement? That I see some those little yellow circles with some ages, but where are those ages coming from?
Yeah, so this is the work we did with the yellow dots. So I'll run you through that. But
Good.
you're right, like 10 kilometers of Precambrian rocks. We really have rarely have fossils. In this
Yeah.
case, a nice teaser here down in the H here. So the Horodischia come from this sort of lower part of the stratigraphy. But
Hmm.
in general, we don't have any volcanic rocks to help us with the story.
Right.
So yeah, it's a bit of an unknown. And the work that had been done previously, they thought these rocks were somewhere between a billion and maybe 750 million years, somewhere in
Wow.
there.
Yeah,
So
right,
not
right, right.
yeah, not so well constrained. So
Okay.
we went in and took a bunch of samples, and that's what the little stars and the numbers here are throughout the stratigraphy to see if we could do a better job on trying to understand how old the rocks were or are. So I'll just move to the next slide.
Very
No,
exciting. Very exciting.
yeah, let me. progress here. So
Okay.
here's some of the rocks look like because I can't take you there today, but you can
Mm,
see that there's some beautiful super mature quartzites,
mm.
the white ones up the top left. There's different sedimentary features that you could be on a beach yesterday with some of these ripples.
Yes.
Yeah, some beautiful shales with pyrites.
Wow.
Um, some clastic dikes, some growth faults, which suggest that this basin was extending as it was being deposited.
Mm,
And the idea is that the basin deepens as you go to the east. So some of the
hmm.
stratigraphy is probably equivalent laterally as you go to the east. Sorry,
Love it.
I'm
Yeah. It's
trouble
okay.
getting to my next slide. Here we
It's
go.
all
No?
right.
Here we go.
Thanks.
Okay, so what we did was took these samples throughout the stratigraphy to try and look at the age. So one way to date sedimentary rocks is to look at the tiny minerals of zircon that are
Mhm,
in the rocks. So
mhm.
I'm not sure if you've talked about this before, but as sedimentary basins form, all sorts of rocks are being eroded, and their rubbish basically is being sent into the basin.
Yes.
And zircon is a really useful mineral that allows us to date those detrital minerals.
Hmm.
So we looked at zircon through the stratigraphy, and you can see some of the plots there, which just shows age on the bottom
Mm.
and relative probability on the side. So the little bumps are showing the most common age populations in the zircon at different horizons in the stratigraphy.
Hmm.
Then on the right here, I've got some pictures of monazite. So monazite's another really interesting mineral that we can date. It's a phosphate mineral, contains rare earth elements, and importantly uranium, which means that we can measure the uranium and the lead, and we can understand something about the age. And in these rocks, the monazite is actually forming in the pore space between the sand grains.
Mm.
So it's not a detrital monazite that we're dating. It's actually forming as the sediments after they've been deposited.
I
So you can see
see.
that monazite in the top right is this sort of brighter color phase with lots of inclusions. So the inclusions are all the main part of the sandstone or the siltstone, and then the monazite is growing around that and in the space.
Mm.
So by combining the zircon gives us a maximum age and a sort of a signature of all the source rocks that have gone into building the basin. With the monazite, that gives us a minimum age because that's forming after the sediments have been deposited. Then we can get a better idea of how old the rocks are in the Rocky Cape, and that's what we did. So here's my little zircon and monazite grains in a mount. That's actually how big they are when we're looking at them and trying to date them. So yeah,
Wow.
they don't look very exciting in those tiny grain mounts, but the amount of data we can get out of them is quite extraordinary to try and sort of barcode both the source rocks and the timing of the basin formation.
And I
So this
assume the same process has been done over here in Montana and southern British Columbia as well.
That's right. Yeah,
Mm.
similar work's been done, and you can see the upper belt, some of the upper belt data here in
Oh,
pink,
yeah. Right.
just to show as a comparison. So we can see the signature is quite similar through parts of the Rocky Cape group compared with the upper belt there. And
Yeah.
if we look at the timing of deposition, we can see that there is quite a good overlap with the upper belt and a good part of the lower part of the Rocky Cape group. We certainly have some younger parts of the Rocky Cape group as we go up in the stratigraphy, but we have a nice overlap here in the base.
Hey, can I stop you for a sec? Can you stop your
Yeah,
share, Jackie? I know you've got more, but I'm having a moment right now, and who knows how long it will last. Can you exit your share so we? Yeah, thank you.
sure.
Um, like, what if I flip it around and I say, we've got Rocky Cape here. It's not Belt-Purcell. We've got your Rocky Cape. And that I think a couple of geologists that I'm reading are thinking that the entire collection that we're talking about, your Rocky Cape and our Belt-Purcell, is all exotic. That it's not. I think I've always viewed and I've been taught that the Belt-Purcell is old Precambrian bedrock of North America. It's the western margin of Laurentia, and that, I guess I always just, I didn't, no offense, I didn't think of Tasmania. I thought of either Australia or Siberia or Antarctica, just slowly backing up and kissing the shore during the supercontinent of Nuna, and then you guys take off again. But maybe it was more violent than that. And that we've docked a bunch of your bedrock and then you took away again. I know that's wild, but like, do you have any general reaction to that? Are people talking about that kind of concept?
Yeah, so thinking about Nuna, the Nuna supercontinent, it's a long time ago. So we're talking sort of, I think, amalgamation about 1800 million years ago, when North America, so Laurentia, as it was known,
Yeah,
Australia, East Antarctica, were all in the neighborhood. I think we have some good evidence that there was a collision early on in Nuna that brought these big land masses together. And so I guess the way I think of the Belt-Purcell in Tasmania is that Tassie was somewhere in the middle there, probably connected to East Antarctica. I mean, it's all one and the same at the time, but somewhere in
right,
that middle.
right.
And and that the basin was forming as Nuna was trying to rift apart at about 13 to 1200, maybe 1100 million years ago. Nuna
Okay,
was starting to be unhappy and wanting to pull apart again. And so we know supercontinents have these cycles where they come together, and after a while they get a bit bored and they want to like break up again.
right.
And so that was happening, and as that was happening, that was creating space for sediments. So we had this big basin forming, and so on the American side today, you have the Belt-Purcell, which is super thick, right? It's,
Yeah,
I mean, 20 Ks or so thick,
right.
maybe more.
Yeah,
Um, and so we had a quite a fast growing basin, I think, particularly in the base in the Belt-Purcell. And then in Tassie, we have part of that story as well as the supercontinent is trying to rift apart. And did it rift apart? I think that's another really interesting story. Did it rift
right.
apart then, or actually did it try and was unsuccessful fully rifting? I think
Yeah.
that's something that these rocks can help us with as well. I don't know
Oh,
if we have the answer, but I think we can
no.
try and tease it out from these rocks. Yeah.
Hey, nice job by you. I was pretty wild there, and you talked me back off the ledge. Like, of course, these are like undeformed sedimentary rocks in the Belt-Purcell. This is not some sort of major mountain range. This is not a Himalayan collision. This is way after we're assembling that supercontinent, and we're later than the big impact. Okay, very good.
Yeah.
Um,
Yeah.
but I definitely want to go back to the supercontinent thing, and I think you must have a slide or two once we get through a little bit more data to zoom out and give us a sense of how exactly are we going to slot Tassie into, where are we going to put it specifically on a North American margin? I guess the answer must be in the neighborhood since we're matching it with the Belt-Purcell. Please,
Yeah.
if you feel like you want to go back to your slides, that would be a good
Sure.
time to do that. This is fun. This is a blast.
It's always fun moving continents
Oh
around.
my God.
Yeah.
Yes.
So here's kind of a nice cartoon to kind of get at what we were just talking about. So here
Yes.
at the top left is the zircon data from all the samples we analyzed in the lower part of the Rocky Cape.
Hmm.
So this is age across the bottom, and you can see the main peaks there at sort of 1715, 1790, and 1450, which is a really interesting age, and it actually helps tie in with the North American geology quite well.
Hmm.
Underneath in the orange, you can see the upper belt, and that's a compilation of other people's work. So you can see where the similarities lie between the signatures in the Tasmanian rocks and the upper belt rocks. Um,
Hmm.
and the stratigraphy over here too. So we're talking about the lower Rocky Cape and the Missoula and Lemhi groups.
Yeah.
And so over on the right, we've got the supercontinent Nuna, just a sort of schematic of what that might look like. So at 1.7 billion years, we've got that supercontinent coming together. It's quite happy for a few hundreds of millions of years, and then it's attempting to break apart.
Yes.
If we zoom into where we think this basin is forming, we've got the belt over here on the right-hand side in North America, and Tasmania is sitting, somewhere off to the west.
Hmm.
probably adjacent to Antarctica is what our research seemed to show.
Hmm.
There's definitely basins forming at that time elsewhere in Australia, in
Mm.
South Australia and Northern Australia, but their provenance is quite different. So they don't have a similar zircon record to what we see in Tasmania or in the Upper Belt. So we're thinking that the Rocky Cape Group sits somewhere in here as Nuna is trying to split apart. And does it quite split apart, which is where I was going before? We're not sure because I guess the prevailing wisdom is that Nuna breaks up. Laurentia and Australia and Antarctica actually go their separate ways quite
Yes.
significantly. A big ocean basin forms,
Okay.
and then they seem to come back together in the next supercontinent, Rodinia,
Yes.
500 million years or so later. So is that what happened? Or actually, did they never really break up properly
Hmm.
at the end? That's something that's I think people are still working on.
Well, that's a really interesting point for a couple of reasons. One, I've always confused Nuna and Rodinia. I don't, are they here are you guys here the whole time? And then you take off like 780 million years ago or whatever when Rodinia finally breaks up, or not. And so that's new to hear you say that right now that but what evidence do we have that there was a decent ocean between Nuna and Rodinia?
That's a really good question because we don't have great evidence for it. And so
Hmm.
that's what's been perplexing. So the the reason that the plate models show this breakup is because we have paleomagnetic evidence that
Ah.
Australia and Laurentia were quite widely separated at about 1.2 billion years.
Hmm.
So that paleomag evidence has been used for this broad ocean basin. But the problem is then you need to bring them all back into basically the same positions for Rodinia. And like you say, we don't see this collisional orogenesis. We don't see these mountain building events. We would expect a
Yeah.
huge mountain forming episode as we bring these continents back together along the margin of Laurentia and Australia, East Antarctica. And we don't really see that. And so that's been something that people have, including me, have worried about. And I think we're still trying to figure that out. There's some different models of how you could do it. You could kind of bury that mountain range in Antarctica and just say, like, maybe we don't see it because it's under the ice. So that was
Ah.
one of our models. But maybe another model is if there's another way to explain the paleomag data, maybe the continents didn't actually properly rift apart
Hmm.
between and Rodinia at all. And I think the Belt-Purcell and the Tasmanian rocks can help us with that.
Very interesting. Do you have any more slides, Jackie?
Yeah. Just to show that we're still at the same period of time, about 100 million years ago.
Yes.
And this is nice work that's just recently come out by my colleague Cherie, and she's looked at mineralization. So one of the things in the Belt-Purcell is really well endowed with sedimentary hosted ore deposits, right? And
Hmm.
so our thinking is if Tasmania is the same stratigraphy, perhaps there's ore deposits in Tasmania that we haven't found yet. Maybe it's a good place to look for similar ore deposits.
Hmm.
So she went and had a look at some of the prospects in northwest Tasmania and dated a whole bunch of different things, including the lead sulfides, but zircon and other things. And you can see that the prospects have ages that are very similar to some of the ages in the Belt-Purcell. So some of the Galena data over on the right-hand side.
Yeah. Yeah.
In this model, there was a sort of a strengthening case for Tasmania, the Rocky Cape Group part of Tasmania being actually part of the same basin as the Belt-Purcell at this time and was affected by these fluid flow events that have moved metals around and deposited metals within the basin. So that's kind of intriguing. So we don't have deposits that are as economic as have been found in the Belt-Purcell yet, but perhaps that throws open new opportunities for Tasmania in terms of looking for new ore deposits in these rocks. So that's an interesting one. And then I guess the other thing that, as we've been talking about, this transition from Nuna to Rodinia, what
Yes.
really happened? And so the upper part of the Rocky Cape Group Over here on the left is includes the Irby siltstone and the Jacob quartzite, quite thick packages of rocks. And a couple of years ago, a PhD student of mine, he went and spent some time in the US and spent some time in the Grand Canyon and had a paper out comparing actually the stratigraphy between these upper parts of the Rocky Cape Group, which is quite a bit younger than the
Hmm.
lower parts we've been talking about, and
Hmm.
comparing the signature of the zircon. You can see on the right-hand side there the age of the zircon, but also looking at hafnium, which is another isotope that we can look at in zircon, which gives us some flavor of the signature of the source rocks. And he showed that there was some really nice similarities with the Grand Canyon and the upper part of the Rocky Cape Group. So at that in that period of time, we're talking about Rodinia.
Yes,
So so now we've crossed over, which is why it's confusing. Now we're in the Rhodinian times, but we're
right.
still seeing these connections, and we're seeing the connections in Tasmania in the same basin, right?
Okay.
So this has really led us to think, yeah, maybe there's a longer lived connection. And I just had one more slide that shows how that might work. So
Wonderful.
Jack's model for Rodinia here, it's quite complicated. But basically, if we look at this one first, we've got Laurentia in the purples.
Yes.
Tasmania, various bits of Tasmania are sitting off here at the bottom, and a little bit of Antarctica is sitting there too.
Uh,
And Australia and another big chunk of Antarctica here in green. And so as Rodinia is assembling, they're sort of sliding past one another until they form at the top there a Rodinia configuration where Tasmania's sitting off the bottom here. So another option is actually Tasmania's more in the middle across from Belt-Purcell the whole time. And I think
yeah.
that's maybe the model we prefer now.
Mm,
But in this paper a couple of years ago, there was an argument to make that maybe we were closer to the Grenville origin for reasons that probably another story. But south of Tasmania, we actually have a big lump of crust that's underwater. It's called
mm,
the South Tasman Rise,
mm,
and it has ages that are quite distinctive of the Grenvillian origin in North America. So
mm.
there was a temptation in this paper to kind of push us towards further to the south, which was interesting. But perhaps actually Tassie sits, with the connections we've just been talking about with the Belt-Purcell the whole way through right up to the top, that maybe we could sit further to the north. And that kind of works come through in the reconstructions to the right too, where we eventually Rodinia breaks up, uh, you know, between sort of around 750 million years ago. So perhaps we had Tassie sitting down here, but another option is perhaps we had Tassie sitting up here, and as Rodinia broke up, Tassie was either with Laurentia or with Antarctica, but eventually it came off and collided into mainland Australia. So it's Tasmania's had a complicated history, and it's been related to North America for longer than it's been related to Australia.
Isn't that wild?
Yeah,
That statement right there, that's the headline of this whole thing.
yeah,
That is so cool.
yeah,
Would you mind stopping your share? We can
sure.
do a couple final comments here. This is
Yeah,
um, I did a supercontinents lecture that I filmed it. It was a public lecture and I put it on YouTube. And this was like before the pandemic, I guess 2019. And I kept reading all these papers, and it was Australia was off the shore of us. So no, 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 Siberia, no, a piece of China's craton. You've heard it all before a million times, but it does feel like in the last decade, and you sounds like you've been in the middle of it. There is a brand new set of data that's helping to place these pieces in different locations, and it's so pleasing to hear it directly from you. And then also, I guess I'm comforted because I was so confused between those two supercontinents. I guess everybody else is too, essentially, with some of these major questions.
yeah, for good reason. Yeah.
Yeah. I think my final question is I'm just curious about you personally. Are you teaching as well as doing research? And was that 2014 paper your PhD, or were you a young professor at that time?
Yeah, in 2014, I was a postdoctoral researcher,
Okay.
sort of a junior researcher at the time, so after my PhD.
Hmm.
Yeah, and these days I do teach a little bit. Now I work in Antarctica, mostly focused in Antarctica and trying to understand how the Antarctic continent was built over many, many billions of years and what that means for the ice sheet, how that impacts the ice sheet's behavior today,
Yeah.
and also what we can learn about how the ice sheet is changing and has changed in the past. So it's quite a different application of geology, my geology skills now in working with the ice sheet community, which is really exciting because there's so much to learn.
Yes.
Um, but yeah, the Tasmanian work, as I said, it was kind of an opportune moment where these fossils were found and I was around and I was keen. So I was really lucky to get into that line of work. And then students and colleagues have sort of taken that work further and it's still opening up new possibilities today for further work. I'd love to get back into it. I was talking with Jack Mulder just yesterday, actually, and we were like, "Oh, there's so much more we can do. We need more students." Um, so yeah, Tassie will always, I think, always have opportunities for more exciting research, and hopefully I can be part of that. But yeah, day to day now, I'm thinking about Antarctica, and trying to piece together the puzzle there.
Beautiful. Well, you did a beautiful job here today, and I'm so grateful to you. Thank you for your time. Would you please hold the line? I'm going to stop the recording, but we'll visit for another couple of minutes if you don't mind. But Jackie, thank
Sure.
you so much. You did a great job here. Thanks.
No worries.
Okay. Bye-bye.
Bye.